how we can use waveRAPID to optimize the data. And I would like really to thank a lot to Amit Sharma from Arcturus for sharing the materials for testing. And I would like to show you what way we went when analyzing the sample. So the goal was to measure binding kinetics between protein and small molecule, and to compare also waveRAPID and traditional multicycle kinetics. What we know about this binding at the beginning is that there is some data from SPR available, and it's suggesting that the affinity is very weak. So there is dose-dependent binding, but it seems like the interaction is very, very weak. Well, that's good, right? Wave can really resolve fast binders. Let's give it a try. So first, we repeated the measurement that was done with SPR. And what we observed here is, yes, there is dose-dependent binding. However, we can see there is no saturation. So we can see that the distances are getting higher and higher, what also you can see in these equilibrium plots. So it's very difficult for the software to fit Rmax. We really don't know where this curve will plateau. But what we can also see here, it looks like there is some slowly dissociating component visible. So maybe we can use waveRAPID to quickly check if it's something in this if this information will be helpful. Maybe this binding is actually tighter, not that weak. Okay, let's run waveRAPID. As we don't know much at the beginning, we only see that there is some binding and maybe it's tighter than we expected. Let's start with intermediate binder settings to see where are we going. So that was the initial waveRAPID experiment done on these samples. And what we can see here is actually looking already quite good. Some of you would say that you are happy with this. Some of you would say, okay, maybe we can decrease the concentration, right? So what we see here is like there is some biphasic behavior. There is like faster and slower component here. So it deviates from one-to-one model. There is very fast saturation. So this 10 micromolar is definitely too high concentration for this. But it looks like it's really much tighter than we expected. Okay, let's optimize. I decided to lower the concentration a lot, but at the same time, I gave it a little bit more time. So I'm moving from intermediate binder settings towards tight binder settings where we have higher, like longer time, but lower concentration. And it already looks good. We are still saturating quite quickly, so maybe there is even lower concentration that can be used. But now we can see that it is much better fitted with one-to-one model. So maybe we can give it one more step with waveRAPID. Okay, let's lower concentration tenfold, but also give it a little bit more time of interaction. And that looks good now. So we can fit it with one-to-one. We have good parameters and low errors. And also, we actually have a very good agreement with the ITC published data. So you can see here we got like 4 nanomolar affinity. Published data is showing 7 nanomolar affinity from ITC. And with information about affinity from waveRAPID, and these experiments were really not very long. So from this with this information, 4 nanomolar more or less affinity, we can very nicely prepare multicycle kinetics. We know we should go like more or less tenfold higher with concentration and tenfold lower. So we can prepare a good concentration range. We know more or less what is the on rate. We know how much time we need for this compound to dissociate, and we can easily set up multicycle kinetics knowing all of this. With this multicycle kinetics, we can see that there is good agreement still with the published ITC data, but also good agreement between waveRAPID